Okay, so Europe has set this huge goal for itself, a completely climate-neutral energy grid by 2050. Now, a new study lays out a fascinating blueprint for how to get there, and you know what? It might just be cheaper and a whole lot smarter than anyone thought.
So that's the big question, right? The monumental challenge facing an entire continent. How do you completely unplug from fossil fuels? It is a massive, massive undertaking. But the answer might not be about just building more of everything. It's really about building smarter. You see, hitting this goal means a lot more than just dotting the landscape with new solar panels and wind farms. It actually requires a complete overhaul of the entire grid, that huge, vast network of high-voltage lines that's basically the continent's circulatory system for energy.
Right, so let's think about this like a giant puzzle. It's not just about having all the renewable pieces, it's about how we connect them all together to see the full picture. And it turns out the way we plan this whole network, well, that's everything. And the key concept here, the big idea, is something called integrated infrastructure planning. Think of it like this. If you were designing a city's entire transport system, you wouldn't build the train lines without ever talking to the bus company or planning the roads, right? It's all about making everything work together, seamlessly. But here's the problem. Right now, that's not how we do things. Energy planning is super fragmented. Each country often just does its own thing. And the different energy types, electricity, gas, and now hydrogen, they're all planned in their own separate silos. This whole fragmented approach forces us to a really critical crossroads, where two fundamental questions are going to shape our entire energy future. So what are these two big choices? How Europe answers them is going to determine the cost, the efficiency, and let's be honest, the ultimate success of this entire green transition. Okay, first question is all about perspective. Do we take a national view where every single country tries to be self-sufficient, building enough power plants and storage just for itself? Or do we take a European view where countries cooperate, sharing power across borders when, say, it's windy in one place and calm in another? And the second big question is about how we plan the networks themselves. Do we take a sectoral view, planning the electricity grid, the gas grid, and the new hydrogen grid all in their own separate worlds? Or do we go for a cross-sectoral view and plan them all together as one big interconnected system? This is where the study gets really, really cool. Researchers at the Fraunhofer Institute took these two sets of choices and combined them to model four totally distinct possible futures for Europe's energy grid. They used this really powerful open-source tool to simulate the entire European energy system, year by year, all the way to 2050. So they ran four different scenarios, with each one being a unique combination of those choices we just talked about, national versus European, and siloed versus integrated, all to find the single best path forward. So here they are, those four potential futures. On one extreme, up in the top left, you've got SN. That's sectoral and national. You can think of this as pretty much business as usual, where everyone's just working in their own little bubble. Then, on the complete opposite end, in the bottom right, is CE, cross-sectoral and European. This is the fully connected, fully cooperative vision. And the other two are sort of hybrids, falling somewhere in between. So, after running all the numbers, after simulating decades of energy production and consumption across an entire continent for all four of these futures, what did they find? Well, the verdict was incredibly clear. The CE scenario, the one that combines that Europe-wide view with integrated planning, it isn't just a little bit better. It is the runaway winner, and not just by a little, but by a huge margin. Let's actually look at the numbers to see just how big a difference this approach really makes. Okay, first, let's talk capacity. In that fully connected CE world, Europe would need to build 15% fewer onshore wind turbines. Just think about that for a second. That's thousands of turbines that we wouldn't need to manufacture or install. We're talking about an immense amount of land, materials, and money saved. And this is even more staggering. Look at the reduction in backup power plants. Those are the ones that pretty much just sit idle until there's an emergency. By sharing resources across borders, Europe would need 505 gigawatts less backup capacity. To put that in perspective, that is roughly the equivalent of 500 large nuclear power plants worth of infrastructure that we just wouldn't have to build. It's just incredible. And the savings just keep on coming. Because the whole system is planned as one, you need less capacity to produce green hydrogen, and you need to store less of it too. Literally, every single part of the system just works more efficiently because it's all connected and coordinated. And here it is, the bottom line, the cost. This chart shows the total system cost for each scenario from 2030 to 2050. And look at that. The fragmented, business-as-usual approach is by far the most expensive path. The fully integrated, cooperative CE model, it's the cheapest. And the difference isn't small. We're talking about hundreds of billions of euros saved over just 2 decades.
So what does all this data really mean? What are the real-world consequences of choosing one path over the other for Europe? And really, for all of us?
It means this isn't just some technical exercise, it's a real blueprint. By planning smarter, by working together, Europe can actually hit its ambitious climate goals faster, with greater energy security, and, this is the crucial part, at a lower cost to absolutely everyone. So, why should you care? Well, because lower system costs directly translates to lower energy bills for you and for businesses. A more connected grid is a more secure grid. It's way less vulnerable to shocks. And building less infrastructure means we get to preserve more of our natural landscapes. So this isn't just an abstract economic model, it's a plan for a more resilient, efficient, and affordable future for every single person. The researchers themselves put it best. The real magic here, it doesn't happen when you try to perfect each little individual piece of the puzzle on its own. The biggest wins, the lowest costs, and the fastest transition, they all come from stepping back and optimizing the entire system as one. So the data shows a really clear path forward, a future that is both climate neutral and economically sound. The technical blueprint is right there. The real challenge, it seems, isn't engineering, it's cooperation. That's all for this explainer. Thanks for tuning in.